Good morning, HOD Professor Mr. A.K. Chaturvedi sir, my seminar guide Mr. Rajan Kari sir, seminar coordinator Mr. D.P. Sharma sir, all faculty members and examiners and all my fellow mates. I am Sheetal Verma, pursuing my BTech in Mechanical Engineering from University Department of Rajasthan Technical University, Kota. Today, I am pleased to be here to present my seminar presentation on the topic of low-cost refrigeration system by using LPG. So, this is the overview of my work. Now, let's come to the topic that what is the LPG refrigeration system and what is the need to invent it. So, as we know that in India, more than 80% of the domestic refrigerator utilizes HFC 134A as a refrigerant due to excellent thermoplastic properties and thermodynamic properties. But HFC 134A has a high global warming potential of value 1300, and also we see in our surrounding that supply of continuous electricity is still not available in the several areas of country and in the world where the refrigeration of food and medicine can be preserved. According to the second law of thermodynamics, heat is virtually pumped from a low temperature to high temperature when the external heat or power is given to the system. So, to solve this major crisis, we need to invent such a system that reduces these environmental losses or which can be done without electricity. So, researchers found an alternative approach in the form of LPG refrigerator, which consists of parts like LPG cylinder, capillary tube, evaporator, pressure gauge and high pressure pipes. Here is the working of this system. When the high pressure LPG passes through the capillary tubes, it expands, and after the expansion, the phase of the LPG is changed and converted from liquid to gas. Then it passes through the evaporator, where it absorbs the heat and produces the refrigeration effect. After the evaporator, it passes through the gas burner, where it burns. There are lots of advantages of this system, like use of LPG as a refrigerant improves the overall efficiency of the system by 10 to 20%. The ozone depletion potential of the LPG is 0 and global warming potential is 8, which is significantly negligible as compared to other refrigerants. Apart from environmental friendly, use of LPG also gives us lots of cost advantages. There is 60% reduction in weight of the system due to higher density of LPG. This feed also works without electricity. Running cost of the system is 0. It also eliminates and leaves the compressor and the condenser. Apart from this advantage, it also has some disadvantages. Like efficiency of the system is poor. Leakage of the LPG causes the blast, which is very dangerous. And repairing and servicing of the system is difficult. And the system is very bulky. This system can be used in various applications, like in restaurants where continuous cooling and heating is required. It can be used in chemical industry for refrigeration purpose. It can be useful in remote areas where the electricity is not available. It can be used in refineries where consumption of the LPG is high, and most importantly, it can be used where the supply of electricity is rare or not continuous. Here is the references. Any questions?
Yes. Why we choose LPG as a refrigerant?
Yes, we choose LPG as a refrigerant because the coefficient of performance of LPG is higher than the other refrigerant, and LPG is also cheaper and possesses an environmental friendly nature with no ozone depletion and global warming potential.
I have another question. Why not we use R33A because it consists 0 ODP value?
Yes, we can use R33 or 134A because the ozone depletion potential is 0, and it also has some same characteristics like 134A. But the global warming potential of the R133 is very high, which causes harmful effect on environment. And other hand, LPG produces no harmful effect on environment. And also, the coefficient of performance of LPG is high as compared to R33. Thank you.